the James Webb Space Telescope has made an extraordinary discovery. Beams of light seemingly radiating from an urban area emanating from a location millions of light-years away. This finding has rekindled interest in the possibility of extraterrestrial life. The telescope turned its attention to Proxima Centauri b, the closest exoplanet to our solar system, and detected unusual brilliant bursts of light. Could these emissions be signs of an alien civilization? Tune for more updates. For years, both scientists and the general public have been captivated by the idea of life beyond Earth. Any evidence hinting at the presence of life elsewhere in the universe has been met with great excitement. But a groundbreaking moment occurred when the James Webb Space Telescope presented clear evidence suggesting that life might exist somewhere in space. While scanning the universe, this powerful observatory made an astonishing discovery. It detected lights on a faraway exoplanet that resembled the illumination from extraterrestrial cities, sparking the possibility that an alien metropolis might exist on that distant world. The theory has generated considerable enthusiasm within the scientific community, offering the hope of a breakthrough they have long anticipated. It points to the potential existence of intelligent beings and civilizations operating in ways we are only beginning to understand. The city-like lights were observed from an impressive distance of 4 light-years. NASA engineers were amazed, pondering just how long these signals may have been visible in space, waiting for our technology to advance enough to detect them. David Kipping, astronomer at Columbia University, described the planet where these lights were found as uniquely complex. Many rocky planets that absorb sunlight and release energy as infrared radiation. This exoplanet behaves differently due to its special relationship with its star Proxima Centauri. This discovery made by the James Webb Space Telescope highlights the telescope's crucial role. Its ability to capture infrared light was key to identifying the unusual behavior of Proxima Centauri b, providing insight into the planet's atmospheric conditions. Researchers are planning to continue using the telescope to study the planet's atmosphere in greater detail, hoping to determine whether it might be habitable. The James Webb Space Telescope is particularly sensitive to infrared wavelengths, enabling it to observe Proxima Centauri b even at. While many telescopes struggle to detect faint signals in the vast darkness of space, Webb excels at picking up even the faintest glimmers. Makes it an ideal instrument for confirming whether the alleged city lights on the dark side of Proxima Centauri b are real. The telescope can detect artificial light in space as long as it falls within a very narrow frequency range, much narrower than the light emitted by typical stars. Proxima Centauri b has a dynamic interaction with its star which heavily impacts its environment. Like many planets that orbit stars, it absorbs significant energy from Proxima Centauri. As the planet orbits its star, it experiences cycles of day and night. Much like Earth, Proxima Centauri b experiences intense heat during the day and cooler temperatures at night. Temperature variation on Proxima Centauri b is extreme, which is largely due to its composition. For example, if the planet has an atmosphere, the temperature difference between day and night would be enormous, with one side becoming scorching hot and the other freezing. This dramatic temperature fluctuation is a crucial area of study for astronomers as it offers vital clues about the planet's atmospheric structure. The James Webb Space Telescope, with its ability to detect infrared radiation, can examine the planet's thermal emissions, offering further insight into its atmospheric properties. Interestingly, the orbit of the James Webb Space Telescope around Earth aligns with the orbital cycle of Proxima Centauri b, allowing scientists closely track the planet's daylight cycles every 11.2 Earth days. Proxima Centauri b has an atmosphere. The next step will be to analyze its chemical composition to determine whether it could support life. Finding elements like oxygen, water vapor, and methane would indicate that the planet might be capable of sustaining life. While the James Webb Space Telescope is ideal for examining planetary atmospheres, it is not designed for all tasks. It is particularly skilled at identifying water vapor, carbon dioxide, and methane, but is less adept at detecting free oxygen, an essential sign of life. Still, the telescope can search for other important indicators like ozone, which suggests the presence of a healthy atmosphere. As scientists analyze the data gathered by the James Webb Space Telescope, the search for distant worlds continues. This effort is bringing humanity closer to answering the age-old question of whether we are alone in the universe. It's worth noting that the James Webb Space Telescope can only observe a limited number of exoplanets close to Earth. For more in-depth studies of planetary atmospheres, astronomers will rely on ground-based observatories like the extremely large telescope ELT, which is set to begin operations in 2027. The ELT is designed to provide a closer look at the atmospheric structures of distant exoplanets, offering more precise data on their potential to support life. Excitement is growing for the launch of future space telescopes such as the ELT. In the meantime, the James Webb Space Telescope remains an invaluable asset for exploring distant exoplanets. Despite its limitations, the Webb Telescope continues to provide vital information that could dramatically alter our understanding of what exists beyond our solar system. Researchers have ambitious plans for future space telescopes. These new instruments will incorporate technologies that reduce starlight interference, allowing for better observations of the faint light reflected by exoplanets. Much like using your hand to shield your eyes from the sun to see more clearly, these new telescopes will block out bright starlight, making it easier to study the light reflected by distant planets and analyze their atmospheres to determine whether they might support life. However, this is no simple task. Stars are incredibly bright and often vastly outshine their surrounding planets, making it difficult to detect the faint light that planets reflect. To overcome this challenge, scientists are working on innovative techniques. Method is the coronagraph, which is placed inside a telescope to block out starlight while allowing the planet's light to pass through. By carefully shaping the light waves, coronagraphs can significantly reduce the star's brightness, making it easier to detect the faint light from planets. Another promising technique is the star shade, a large flower-shaped spacecraft that will fly in front of a telescope positioned thousands of kilometers away. The star shade blocks out starlight before it enters the telescope, allowing only light from exoplanets to reach the instruments. This method could be particularly useful in observing planets within their star's habitable zone where liquid water and potentially life might exist. These advanced technologies require exceptional precision. For instance, the alignment of a star shade must be perfect to fractions of a millimeter over vast distances. Moreover, these innovations must overcome the limitations of space missions such as miniaturization, energy efficiency, and the ability to withstand the harsh conditions of space. Despite these challenges, the potential rewards are enormous. Successfully observing and analyzing the atmospheres of exoplanets could lead to the discovery of signatures, chemical signs of life like oxygen, methane, or water vapor in specific ratios. These molecules could indicate biological processes suggesting that life exists beyond Earth. Researchers are also exploring ways to directly image distant exoplanets in greater detail. Future telescopes could be equipped with advanced adaptive optics which correct distortions caused by Earth's atmosphere or the telescope's movements, producing sharper images. Combined with starlight blocking technologies, these improvements would allow scientists to not only detect exoplanets but also map their surfaces and study their climates. This type of imaging would represent a major leap forward in our ability to study exoplanets and make informed conclusions about their potential to support life. The development of next-generation space telescopes marks a significant advancement in our search for life beyond Earth. By improving our ability to observe distant planets, we are getting closer to discovering whether life exists elsewhere in the universe, which could drastically change our understanding of our place in the cosmos. The future of space exploration and the hunt for extraterrestrial life is moving forward at an unprecedented pace. As scientists and astronomers delve deeper into the mysteries of distant exoplanets, the James Webb Space Telescope is ushering in a new era of cosmic discovery. The data it collects is helping astronomers uncover groundbreaking revelations about the structure, composition, and potential habitability of far-off worlds. With each new piece of information, we move closer to answering the ultimate question: is there life beyond our planet? The discovery of Proxima Centauri b is just the beginning of what could be a pivotal moment in our exploration of extraterrestrial life.